Did you know that buried inside your cells, it appears that there's a biological clock that can predict how fast you're aging, and scientists are getting much better at decoding it? I'm Sophie, a third year neuroscience PhD student, and I came across a paper that was published just yesterday that I found particularly fascinating. So, researchers led by a team from Harvard Medical School have analysed gene activity in over 11,000 samples, which were from over 25 different tissues from 4 different species, including rats and humans. And they use these to build what they call a transcriptomic aging clock. So, rather than just looking at chronological age, this clock gives us a picture of what aging really looks like at the cellular and molecular level by looking at gene expression changes over time. So, what's really interesting is that they found this clock was affected by factors that we already know play a role in lifespan and aging, such as radiation exposure and inflammation, suggesting that it might capture genuine biological aging processes rather than just the passing of chronological time. Now, to be extremely clear, this is not going to give you a prediction of how long you're going to live, and it's definitely not going to be used in clinical practice anytime soon. But it is super helpful to understand at a population level, and scientists have suggested that they could use this clock to assess how effective treatments are at slowing this biological aging at a cellular level. So, some interventions might make your clock look older, and some might make it look younger. One thing I've realised throughout my PhD is that scientists can get very stuck in their particular niche. So, I'm doing my best to read one new paper from a different area of science each week. However, this does mean that I'm definitely not an expert in this field, and particularly not an expert on aging biology. So if you know more about this paper, or you are an expert in this field, or you know more about it than me, then please do comment below giving a better explanation or giving some more context to this, as I would love to hear your thoughts.